So one thing I can look at is I could do tests to see if there's a difference in the mass before and after. Now, if you're looking here, then there's actually an issue that there's a significant positive difference, then there's almost no difference, and then there's a fairly significant negative difference. So if I was to do something ridiculously silly like this, so doing compared means and do paired t-tests, and I pick initial mass as variable 1 and final mass as variable 2 and press OK, this is going to show that there's a significant difference because there are more categories where there's a difference than ones that aren't. But the difference that it's going to show is not the real difference, because it's different at each one of the different levels of salt concentration. You can't say that there's one difference that applies across all the different concentrations. So that's not actually a valid comparison to make. What you'd want to do is split the data set into each of the different concentrations and do the comparison for each of them. If I go to this data set, so if I take all the ones that salt concentration of 1, Control C, and I create, actually, what I can do is I've got that set of data saved, then I can just delete out, clear all of these rows. So if I clear all the rows but the first ones, where you've got that strong difference, so I clear all those, and I save this as another one, another version, so I'll call that potato osmosis, and this is 1 molar. 1 molar. Now I can do the comparison. So now I go to analyze, compared means, paired sample t-test, initial and final, press OK. Now I get a significance of 0.04, so it's much more highly significant than before. The t-value is massive, and the mean difference between the two in its confidence interval is from 0.37 to 0.65, whereas if I did it averaged, it was from 0.05 to 0.049. So this is now a realistic and correct t-test. What I'm wondering is, could I have kept, so let's file and open. I want to reopen the file that I just had with the full data set. I'm just thinking if I could have put a filter on doing the compare means, because sometimes SPSS allows you to do filters. So if I do paired samples t-test and I do variable 1 is initial, variable 2 is final. Is there any other thing that I can set? No. I'd have to do inclusion and exclusion criteria, which are a bit annoying. So the easiest way would be to create a separate file for each of the different concentrations. It's a bit tedious, but it would work. Now, what else can I do? The most obvious thing to do is to do a regression. So to do a fit of the curve that you get between the salt concentration and either the final mass or the difference. Now I can use the final mass here because most of the initial masses are about the same. The differences between them are very small, so they're practically all the same of 2 grams. So all of the difference you can see in the final masses. So how am I going to do a regression and fit that curve? So if I go down to regression and I go to curve estimation, because it's not a linear model, I haven't converted it to anything linear, so if I do curve estimation, so I can put the dependent variable is going to be the difference. The independent variable is going to be salt concentration. It's not a linear model. Which sort of shape do I expect it to be? Well, I can put on quadratic because that will give a certain kind of curve. It's not an S-shaped curve, so that's the shape of curve you get for kind of like kinetic curves. So growth and exponentials you've seen before. So exponential going up very rapidly and growth as well. Logistic is very much like an S-shaped curve. So it goes a long flat, a sharp rise, and then it flattens off in a peak. A power curve is a very steep ascending curve. A cubic curve has two turning points, so it's a maximum and a minimum. Whereas a quadratic either has a maximum or a minimum. So in this case, probably a quadratic is the best one to do. I'm going to display the ANOVA table as well, because that gives you some diagnostics of a fit of a curve to the data. And go for OK and see what happens. So it's plotted the curve with the difference, so you've got observed, and there's the quadratic function through the middle of them. It's got a very good significance, so it's a very good fit to the data. The curve is dependent on salt concentration squared, and a constant. So the total equation will be the change in mass is dependent on 2.68 times concentration of the salt minus 1.752 times concentration of salt squared minus 0.405 will give you the difference. The F statistic is massively high, the significance is very highly significant. The R value is 0.973 and the R squared value is 0.946, telling you that almost complete dependence of the change in weight is dependent on the salt concentration. That is a very good model.